What was polarization of light, students? A very unique phenomenon. Closely lying point objects, clear, unique and distinct. A phenomenon where vibrations of polarizing angle or Brewster's angle emit light waves of same wavelength, same frequency. Hello students, in my yesterday's session, we started talking about the phenomenon of diffraction of light, where we told it is bending of light. So diffraction means bending of light at the edges of obstacles and then spreading in the geometrical shadow region. We also differentiated between Fresnel's diffraction and Fraunhofer diffraction, and finally we discussed about the resolving power of a microscope. Continuing my discussion today, we will discuss about the resolving power of a telescope, as we did in our yesterday's class, where we learnt resolving power of a microscope. In my today's class, we shall discuss about resolving power of a telescope. Now students, what was resolving power? Resolve, split, break, where we told the ability of an optical instrument to produce clear, distinct images of two closely lying point objects, clear, unique and distinct. That is what we called as resolving power. Today, we shall understand resolving power of a telescope. So what is a telescope? A telescope is again an optical instrument used to see far away objects, distant stars, to observe distant planets. We use something called as a telescope. So a telescope is an optical instrument used to see far away objects, distant objects. Now, we will try to understand limit of resolution of a telescope. When it was microscope, it was that minimum distance between closely lying point objects. Two point objects which were very close to each other. But when it is telescope, it is angle. It is the angle subtended by the two distant objects, faraway objects, whose image appears to be just resolved. So, when I am talking about telescope, it is the angle subtended by the two faraway objects, distant objects, whose image appears to be just resolved, just separated. And it is given by the expression d theta is 1.22 lambda divided by d. 1.22 lambda divided by d, where lambda is the wavelength of light used and d is the diameter of the objective of the telescope. So students, limit of resolution with respect to a telescope is some angle made by whom? The two distant, faraway objects whose image appears to be just resolved, and it is given by d theta equals 1.22 lambda divided by d, where lambda is the wavelength of light used and d is the diameter of the objective. Now, resolving power of a telescope, or in that issue microscope, is the reciprocal of limit of resolution. We have studied this even in the previous session. When we talk about resolving power, that means it is the reciprocal of the limit of resolution. So, resolving power is given by d sin theta, or d divided by 1.22 lambda. So, resolving power of a telescope can be increased by using object of larger diameter. So this is about the resolving power of a telescope. Now, just to mention the differences between interference of light and diffraction of light, the first point of distinction, the first point of comparison is the definition of the phenomenons. Interference is the modification in the intensity of light, whereas diffraction is the bending of light waves at the edges of obstacles. So remember always, whenever differences are asked, comparisons are asked, the first point will always be the definitions of the phenomenon. Second one, to get interference pattern, what is very, very important? I require two coherent sources. Two sources which emit light waves of same wavelength, same frequency, and same constant phase difference. Coherent sources. Whereas diffraction pattern, sharp edge obstacles. Here, two coherent sources. Here, sharp edge obstacles. When you analyze the interference pattern, all bright fringes and dark fringes are of the same width. They have the same intensity. Either you consider the bright fringes or you consider the dark fringes, they will always have the same intensity, same width. We have derived an expression for fringe width where we have clearly shown either for a dark fringe or bright fringe, beta is lambda d divided by d. Whereas in the diffraction pattern, central band has maximum intensity. Central bright band has maximum intensity, whereas intensity goes on decreasing on either sides of that central maxima. There is a good contrast between the bright and dark bands, whereas here in the diffraction pattern, contrast is very, very poor. And who explains the phenomenon of interference? It was Thomas Young. And the phenomenon of diffraction was explained by Grimaldi. So these are the basic differences, comparison between the phenomenon of interference and the phenomenon of diffraction. Now, going to a very, very beautiful phenomenon called as polarization of light. Again, very much in the earlier session, I have clearly told that either the phenomenon of interference or diffraction or polarization can be explained only when we consider light is a wave. So, thereby, the phenomenon of polarization is studied under wave optics. We are trying to understand the phenomenon by attributing or by considering that light is a wave. Now, students, if I consider ordinary light, which I treat to be unpolarized light. Light coming out from an source, what I call as ordinary light or unpolarized light. When I say ordinary light, the light will vibrate in all possible directions. So, ordinary light, unpolarized light, where you can observe the vibrations happening in all possible directions. Or making my statement still more precise, this ordinary light will vibrate in all possible planes, in whatever direction possible, in whatever plane available, there is vibrations of light, and hence I call unpolarized light. Therefore then, what is meant by polarization? It is a phenomenon in which the vibrations of light wave, a phenomenon where vibrations of light wave is restricted to a single plane. Light ಎಲ್ಲಾ ಡೈರೆಕ್ಷನ್ಗಳಲ್ಲೂ ವೈಬ್ರೇಟ್ ಆಗ್ತಿದ್ರೆ ಎಷ್ಟು ಪ್ಲೇನ್ಗಳು ಸಿಕ್ಕುತ್ತೆ? ಆ ಎಲ್ಲಾ ಪ್ಲೇನಲ್ಲೂ ವೈಬ್ರೇಟ್ ಆದ್ರೆ ಅದನ್ನ ಅನ್ಪೋಲರೈಸ್ಡ್ ಅಂತ ಕರಿತೀವಿ. ಆದ್ರೆ ವೈಬ್ರೇಷನ್ಸ್ ಆಫ್ ಲೈಟ್ ನ ಒಂದೇ ಒಂದು ಪ್ಲೇನ್ ರೆಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ polarization of light ಅಂತ ಕರಿತೀವಿ. So, in simple terms, when we say polarized light, it is confining the vibrations of light in one single plane. My dear students, to make the understanding more simple, when we talk about light, which is an electromagnetic radiation, it has an electric field vector and a magnetic field vector which vibrate always mutually perpendicular to each other. In the previous sessions, when we spoke about electromagnetic waves, you saw there was electric field as well as magnetic field vibrating in mutually perpendicular planes. Now, I will suppress the vibrations of light along the magnetic field vector. I will not allow light to vibrate along the magnetic field. The vibrations of light will happen only in one single plane along the electric field direction, and this is called polarization of light. So the word polarize means to restrict. Polarize means to confine. So very clearly you can see here, this is the representation of a polarized light vibrating in one single plane. So the meaning of polarization of light is to confine, restrict, or make the vibrations happen in one single plane. And which nature is used to explain polarized light? It is transverse nature of light. Electromagnetic waves, transverse nature. Now we study a very important topic called as polarizing angle or Brewster's angle. Polarizing angle or Brewster's angle. Now, I will consider a transparent medium. Some transparent medium. A ray of unpolarized light, or what we call ordinary light, is incident on the transparent medium. ಒಂದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಂ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಒಂದು ಅನ್ಪೋಲರೈಸ್ಡ್ ಲೈಟ್, beam of unpolarized light is incident on the transparent medium. Now, the ray of light is reflected back. If I observe this reflected beam, reflected light, it is partially polarized. For this angle of incidence, the reflected beam is partially polarized to some extent. Increase the angle of incidence, degree of polarization also increases. For a particular angle of incidence, one particular angle of incidence, the reflected ray is completely plane polarized. And this angle of incidence is called polarizing angle or Brewster's angle. So what is Brewster's angle, students? For some angle of incidence, for a particular specific angle of incidence, reflected light is completely plane polarized. And this is what we call as plane polarizing angle or Brewster's angle, based on which we formulate a very important law called Brewster's law. So what does Brewster's law state? The refractive index. He is talking about the refractive index of the reflector medium, that transparent medium is also called reflector medium, which is reflecting light. So the refractive index of the reflector medium is equal to the tangent of the polarizing angle. N is equal to tan theta p, where theta p is called polarizing angle. So this expression is beautifully understood as Brewster's law. Refractive index of the reflector medium is equal to tangent of the polarizing angle. N equals tan theta p, where theta p was called polarizing angle, and this law is beautifully formulated as Brewster's law. So, what was polarization of light, students? A very unique phenomenon where I am restricting vibrations of light to a single plane. I confine the vibrations of light along a single plane. That is called, yes, the phenomenon of polarization. Angle of incidence for which reflected light is completely polarized, plane polarized, is called polarizing angle, Brewster's angle. And Brewster's law stated that refractive index of the reflector medium is equal to tangent of the polarizing angle. In my next session, we study beautiful phenomena on Polaroids, Moore's law, and so on. Until then, have a nice time. Thank you.